Indices look like harmless, tiny numbers. But in your Cambridge math exam, they are deadly traps designed to completely destroy your final grade.
If you think 2 to the power of -4 equals -16, you will lose all marks. Let me show you why. Imagine a massive, futuristic alien cloning laboratory hidden deep underground. It features glowing containment machines holding very strange and mysterious alien creatures inside. Inside one machine sits a single original alien creature. This creature is the foundation of the process. We will call it the base. Above the machine is a giant mechanical dial. This dial controls exactly how many times the alien base will multiply and clone itself. If the dial is turned backwards into negative numbers, the anti-gravity chamber activates. It flips the entire cloning process completely upside down. In mathematics, the alien is your base number, like the number 7. The mechanical dial is your index, or your mathematical power. Let us look at the rule for a power of 0. Absolutely anything to the power of 0 always equals exactly 1.
8 to the power of 0 equals 1. 1,000,000 to the power of 0 also equals exactly 1. Secure that easy mark.
What happens if we multiply clones? 4 cubed multiplied by 4 squared. We are multiplying the exact same bases together in this equation. Here is the golden rule. When multiplying indices with the exact same base, you must simply add their powers together to simplify it. 3 plus 2 equals 5. So the final answer is perfectly simplified to 4 to the power of exactly 5. Full marks secured. Do not fall for the examiner trap. Never multiply the large base numbers together. Do not write 16 to the power of 5. The opposite is also true. When dividing indices with the exact same base, you must subtract the second power from the first power. 7 to the power of 5 divided by 7 squared. 5 minus 2 equals 3. The correct answer is exactly 7 cubed. Now, imagine wrapping the cloning machine inside another giant machine. This is a power raised to another power. We use brackets for this. 14 cubed, wrapped inside brackets, all raised to the power of 2. In this specific case, you must strictly multiply the two powers. 3 multiplied by 2 equals 6. The mathematical expression elegantly simplifies to 14 to the power of exactly 6. You get the mark. Now we reach dangerous territory. What if the cloning dial is set to a negative number, like 2 to the power of -4? Students panic and write -16. This earns a massive 0-mark stamp. A negative index never makes the actual base number negative. A negative index flips reality upside down. The exact examiner terminology here is reciprocal. It simply means 1 divided by your base number. The negative sign disappears when you flip it. 2 to the power of -4 becomes 1 over 2 to the positive 4. 2 to the power of 4 is 16. So the final correct simplified answer is the fraction 1 over 16. It is easy. What if you have a fraction to a negative power? 2/5 to the -3. Just flip the entire fraction upside down. It becomes 5 over 2, all to the positive power of 3. Then you simply cube the top and cube the bottom number. Now for fractional indices. Squeezing a base into a tiny fraction transforms it into a mathematical root. It splits the alien into pieces.
The denominator tells you exactly which root to take. A power of 1/2 simply means the square root of the base number.
25 to the power of 1/2 is just the square root of 25. The exact simplified answer is just 5.
What if the fractional power has a larger number on top? Evaluate 81 to the power of 3/4 without calculators.
Write down this secret examiner trick. The top number is the power. The bottom number is the root. Always do the root first.
Doing the root first makes the massive number very small and easy to handle. The fourth root of 81 is exactly 3.
Now, we take that 3 and apply the top numerator power of 3. 3 cubed means 3 times 3 times 3, yielding 27.
What if the examiner combines negative and fractional indices? Calculate 8 to the power of negative 1/3. Do not panic at all. First, destroy the negative sign by taking the reciprocal. It becomes 1/8 to the power of positive 1/3. Simply beautiful. Now, handle the fraction. A power of 1/3 means the cube root. The cube root of 8 is exactly equal to 2. The final fully simplified answer is 1/2, or 1/2. You have successfully solved a massive A-star level exam question. Finally, we face the most brutal trap, solving equations with completely different bases. Simplify 2 to the 5th multiplied by 4 cubed safely. Index laws only work if the base numbers match perfectly. You cannot directly multiply a base of 2 with a base of 4.
The trick is to rewrite the larger base using a power. We know that the number 4 is mathematically identical to 2 squared.
Replace the 4 with 2 squared inside brackets. Now we have 2 squared, all raised to the power of exactly 3. Look closely. Use the brackets rule. Multiply 2 by 3 to get exactly 6. It transforms into 2 to the power of 6. Bases match. 2 to the 5th multiplied by 2 to the 6th. Add the powers together. The final exact answer is 2 to the 11th. Let us solve for x. 6 to the power of 10 multiplied by 6 to the power of x equals 6 squared. Easy.
The bases match, so we add powers on the left side. We get 6 to the power of 10 plus x equals 6 squared.
Since both bases are exactly 6, we drop them entirely. 10 plus x must equal exactly 2. Subtract 10 from both sides now.
X equals -8. Always match your bases before using the rules. And remember, anything to the 0 power equals exactly 1, always.
Follow GetYourTutors for more Cambridge Math Masterclasses and secure that perfect A-star grade on your IGCSE exam.